Hello everyone, I welcome you all to this session. And today we will discuss about the problems on inverse transform. In the last class, we have discussed about inverse transform. The equation is used for a inverse transform. Then we discussed on partial fraction method. There are three conditions are there in partial fraction method. The first one is when the m is less than n. The order of the numerator is less than the denominator. And second type of problem is the order of the numerator is greater than or equal to the denominator with the distinct poles. And the last condition is we'll consider the order of the numerator is less than the denominator with similar poles present at the same location. So today we will discuss directly on problems on Z transform with the order of the numerator and denominator is equal, and one more problem we'll solve on the order of the numerator is greater than the denominator. So find the Z transform of the following sequence. The x of z is equal to 1 plus 2z inverse plus z to the power minus 2 divided by 1 minus 3 by 2 z inverse plus 1 by 2 z to the power minus 2. With ROC is mod z is greater than 1. So in this problem, the order of the numerator is 2, m is equal to 2, and the order of the denominator is also 2. So it is not in a proper form. So you need to convert it to proper form. Then you have to apply the partial fraction method. So to convert it to a proper form, you have to use the long division method. Because m is equal to n. So I need to obtain m less than n by using a long division method. So the procedure is I have to divide the numerator by denominator term. So I'll write the numerator z to the power minus 2 plus 2z inverse plus 1, and I'll write the denominator like this: 1 by 2 z to the power minus 2 minus 3 by 2 z inverse plus 1. So I'll try to cancel this term z to the power minus 2 by using the denominator. Now I'll take this term, I multiply by 2, so I'll multiply 2 into this first term, so I'll get z to the power minus 2. Then I'll multiply it for the second term, that is minus 3z inverse plus 2. Now you have minus plus minus, so this get cancels, you get 5z inverse minus 1. Now here you can check, this is actually the remainder. You just check the order of this remainder. The order of the remainder is 1. Now if I'll consider with the denominator, the order of the denominator is 2 and the numerator is 1. So I can stop here itself and then I can apply the partial fraction method. Now I'll write this x of z in the general form as, first I'll write the quotient. The quotient is 2 plus a remainder is 5z inverse minus 1 divided by with the divisor. It is 1 minus 3 by 2 z inverse plus 1 by 2 z to the power minus 2. Now I need to obtain the inverse transform of this particular equation. So for that I'll consider this term separately. I'll apply the partial fraction method. Then based on the ROC, I'll obtain the inverse transform. I'll take this term as x1 of z. So x1 of z is equal to 5z inverse minus 1 divided by 1 minus 3 by 2 z inverse plus 1 by 2 z to the power minus 2. And I'll find out the roots of this equation. You know how to find out the roots. This is the characteristics equation. I can apply using a quadratic equation, you can obtain that. or by using a calculator also you can obtain the roots. So here a is equal to 1 by 2, b is minus 3 by 2 and c is 1. Substitute in the calculator and find out the roots. So I'll get the roots as here 2 and 1. You take the inverse of that because it is in the negative power sub z. So you take the inverse of that. Therefore 5z inverse minus 1 divided by 1 minus 1 by 2 z inverse into 1 minus z inverse. If I multiply these two terms, I should get this denominator. Apply the partial fraction method. The x1 of z is equal to a divided by 1 minus 1 by 2 z inverse plus b divided by 1 minus z inverse. Then cross multiplication, a into 1 minus z inverse plus b into 1 minus 1 by 2 z inverse is equal to 5z inverse minus 1. Now to find the values of a and b, put z inverse is equal to 1. Substitute z inverse 1 is equal to 1 in this. So you'll get b is equal to 8. So this term will be 0. And here I'll get 1 by 2 and this is 4. So b is equal to 8. Put z inverse is equal to 2. Here 1 minus 2. And here this will be 2 by 2, it will be 1. So 1 minus 1 is 0. So this term will be 0. I'll get a is equal to minus 9. Therefore x1 of z is equal to minus 9 divided by 1 minus 1 by 2 z inverse plus 8 divided by 1 minus z inverse. I'll substitute this x1 of z in x sub z equation. Therefore I'll get this equation x sub z is equal to 2 minus 9 divided by 1 minus 1 by 2 z inverse plus 8 divided by 1 minus z inverse. Now based on the ROC, I need to obtain the inverse z transform of this. The ROC given is mod z is greater than 1. And here there are two poles are there, one is at 1, other one is at 1 by 2. So, ROC is given mod z is greater than 1. So ROC is outside the circle with the radius 1. If it is outside the circle, then we'll get right-sided sequence. Now taking inverse z transform of x of z, we'll get x of n is given by 2 into delta of n. So you know that from the table, the z transform delta of n is 1. Similarly, the inverse z transform of 1 is delta of n. So I can directly write it as 2 into delta of n minus 9 1 by 2 to the power n u of n. Because it is a right-sided sequence, so I am multiplying with u of n plus 8 into u of n. Because 1 by 1 minus z inverse, its inverse z transform is u of n. So in this problem, I consider the order of the numerator and denominator are equal. So if it is equal, you have to apply the long division method and in such a way that the order of the numerator should be less than the denominator. So next problem, find the inverse z transform of the following sequence. The x of z is equal to z cube plus z square plus 3 by 2 z plus 1 by 2 divided by z cube plus 3 by 2 z square plus 1 by 2 to z. With ROC is mod z is less than 1 by 2. You can observe here, this equation is given in terms of positive powers of z. Because I solved all the problems in terms of negative powers of z. So better you convert this equation into a negative powers of z. To convert it to a negative powers of z, you take z to the power 3, the maximum power in the numerator and denominator. Here that is 3, right? Z cube and here also z cube. So I'll take z cube outside. So if I take z cube outside, then I'll get the equation as 1 plus z inverse plus 3 by 2 z to the power minus 2 plus 1 by 2 z to the power minus 3. Similarly, in the denominator, we will take z cube outside, then it is 1 plus 3 by 2 z inverse plus 1 by 2 z to the power minus 2. Here these two terms get cancelled, z cube and z cube cancels. Now I'll compare the order of the numerator and denominator. So here you can observe the order of the numerator is 3. And what about the order of the denominator? Order of the denominator is 2. So m is greater than n. Again, this is not in a proper form. So it's not possible to apply the partial fraction method directly. So I have to apply long division method and convert the order of the numerator should be less than the denominator. I write the numerator 1 by 2 z to the power minus 3 plus 3 by 2 z to the power minus 2 plus z inverse plus 1, and write the denominator as 1 by 2 z to the power minus 2 plus 3 by 2 z inverse plus 1. Now I need to cancel this term z to the power minus 3, so I'll multiply z to the power minus 3. So I'll take here z inverse, I'll multiply z inverse to this terms. It is 1 by 2 z to the power minus 2 into z inverse, so it is 1 by 2 z to the power minus 3. Z inverse into this plus 3 by 2 z to the power minus 2 plus z inverse into this plus z inverse. Now this get cancels. Again, even this also get cancelled minus, and this also get cancels minus, it will cancels. The remaining is 1. So here it is 1, so 1 it is. Therefore, I can write the x of z in general form as quotient z inverse plus the remainder divided by the divisor. 1 divided by 1 plus 3 by 2 z inverse plus 1 by 2 z to the power minus 2. Now this is my x of z. So I have to apply partial fraction method, partial fraction to this particular equation. Then I have to take the inverse z transform based on the ROC. For x1 of z is equal to 1 by 1 plus 3 by 2 z inverse plus 1 by 2 z to the power minus 2. I'll find the roots here. I'll find the roots here 1 plus 3 by 2 z inverse plus 1 by 2 z to the power minus 2. The roots I'll find out. The roots are minus 1 and minus 2 will get. And here this is A, this is B, and this is C. And if I substitute in the calculator, I'll get the roots as minus 1 and minus 2. Therefore, I write this as 1 divided by 1 plus z inverse into 1 plus 1 by 2 z inverse. So A divided by 1 plus z inverse plus B divided by 1 plus 1 by 2 z inverse. So cross multiplication, and I'll find the values of A and B. So A into 1 plus 1 by 2 z inverse plus B into 1 plus z inverse is equal to 1. Now put z inverse is equal to minus 1 in this equation. I'll get z inverse equal to minus 1, 1 minus 1, this term will be 0. I'll get A into 1 minus 1 by 2, that is equal to 1. Therefore A is 2. Similarly, put z inverse is equal to minus 2. I'll get minus 2 here, this will be minus 1, so 1 minus 1 is 0, so first term will be 0, and here I'll get b into 1 minus 2 is equal to 1, therefore b is equal to minus 1. Therefore my x of z equation is z inverse plus 2 divided by 1 plus z inverse minus 1 by 1 plus 1 by 2 z inverse. Okay. Now I will take the inverse Z transform depending on the ROC. Here the ROC is given by mod Z is less than 1 by 2. So there are two poles are there. One is at 1 by 2, other one is at minus 1 by 2, other one is minus 1. So if I'll take the mod of that, it's 1 by 2 and here it's minus 1. And here they given ROC is mod Z is less than 1 by 2. So ROC is inside the circle with the radius 1 by 2. So if it is inside the circle, then my x of n is always a left-sided sequence. Therefore, if I take the inverse Z transform this equation x of z, I'll get x of n is equal to delta of n minus 1. So you know that the z transform of 1 is delta of n, and the time shifted version of delta of n, that is delta of n minus k, its z transform is z to the power minus k. So here delta of n minus 1 is there, therefore it is z to the power minus 1. Therefore I can write this as delta of n minus 1 minus 2 into, here this is plus here, so I can take it as a minus 1 to the power n u of minus n minus 1. Again here it is also it is plus, so I can write this as minus 1 by 2 to the power n u of minus n minus 1. So this is standard form, that is a to the power n u of n, its z transform is 1 by 1 minus a z inverse. So here a is minus 1 by 2. Here also a is minus 1. And because this is the left sided sequence, I will multiply the minus u of minus n minus 1. So this is, will get minus, the second term will get minus, whereas here it's a minus is there, so minus into minus it is plus. So therefore it is minus 1 by 2 to the power n u of minus n minus 1. So this is the third possibility, so that here I consider the order of the numerator is greater than the denominator, m is greater than n. So always if m is greater than n, you have to apply long division method, and you need to convert in such a way that m should be less than n. Okay, next problem is find the inverse z transform of x of z is equal to z to the power 4 plus z square divided by z square minus 0.75z plus 0.125. The ROC is mod z is greater than 0.5. You have to obtain the inverse z transform using partial fraction method. So this question is appeared in a model question paper 2. So you need to find the inverse z transform by using the partial fraction method. Again, this problem is given in terms of positive powers of z. So you convert into a negative powers of z by taking the maximum power of z in the numerator and denominator. So here I can observe z to the power 4 is there. You take z to the power 4 outside. The denominator here having z square. So I'll get z to the power 4 into 1 minus, so 1 plus z to the power minus 2 divided by z square, I'll take it outside, 1 minus 0.75 z inverse plus 0.125 z to the power minus 2. So here this z to the power 4 and z square, so z square it cancels, so you'll get z square into 1 plus z to the power minus 2 divided by 1 minus 0.75 z inverse plus 0.125 z to the power minus 2. So I'll consider this particular term separately. Then I'll apply the partial fraction method, and this z square I'll consider the last section. I'll use the time shifting property, and by using time shifting property I'll obtain the inverse z transform. Now if I'll consider this particular term, you can observe here the order of the numerator is 2, right? So I can consider m is equal to 2, and the order of the denominator again it is 2, so m is equal to n. So direct application of partial fraction method is not possible, right? Because m is equal to n, so it's not possible to apply partial fraction method directly. So I have to apply long division method in such a way that m should be less than n. So this is the first step. So you have to apply a long division method and convert the order of the numerator should be less than the denominator. So I'll write z to the power minus 2 plus 1 divided by 0.125 z to the power minus 2 minus 0.75 z inverse plus 1. So I have to cancel this z to the power minus 2. To cancel by using this particular term, I'll take here 8, because 8 into 0.125 I'll get 1, right? So therefore it is z to the power minus 2. So 8 into this z to the power minus 2, again 8 into second term, 8 into 0.75 and get minus 6 z inverse plus 8 into 1. So you'll get 8. So therefore it is minus plus minus. So here 7z inverse minus 8. 7z inverse minus 8. Now I'll write x of z is equal to z square into 8 plus 7z inverse minus 8 divided by 1 minus 0.75 z inverse plus 0.125 z to the power minus 2. So here I'll consider this as x1 of z. I'll apply the partial fraction. I'll find the constant values, then I'll apply the inverse transform. Now consider x1 of z is equal to 7z inverse minus 8 divided by 1 minus 0.75 z inverse plus 0.125 z to the power minus 2. I'll find out the roots here. This is 0.75 means 3 by 4 and 0.125 means 1 by 8. So the roots I'll get here, A is 0.125, B is minus 0.75, C is, I'll take it as 1. Then I'll get the roots as 2 and 4. So then it will be 1 by 2 and 1 by 4. Therefore I'll get 7z inverse minus 8 divided by 1 minus 1 by 2 z inverse into 1 minus 1 by 4 z inverse. Now apply a partial fraction method. Get x1 of z is equal to a divided by 1 minus 1 by 2 z inverse plus b divided by 1 minus 1 by 4 z inverse. So cross multiplication, I get 7z inverse minus 8 is equal to a into 1 minus 1 by 4 z inverse plus b into 1 minus 1 by 2 z inverse. Now to find the values of a and b, I put z inverse is equal to 2 here. If I put z inverse is equal to 2, 2 divided by 2 it is 1, so 1 minus 1 0, so second term will become 0. And here I'll get 2, 1 by 2, so 1 minus 1 by 2, and this is 14 minus 8, so it is 6. 6 is equal to a into 1 minus 1 by 2, so therefore a is equal to 12. Next put z inverse is equal to 4, then this will be 7 into 4, 28 minus 8, so 20, and the here 4 by 4 1, so 1 minus 1 0, so first term will be 0, second term will get b into 1 minus 2, so here it is minus 1, therefore b is equal to minus 20. Therefore x1 of z is equal to 12 divided by 1 minus 1 by 2 z inverse plus minus 20 divided by 1 minus 1 by 4 z inverse. I'll substitute this x1 of z in this equation, it is x of z equation, then later I'll obtain the inverse transform. So x of z is equal to z square into 8 plus 12 divided by 1 minus 1 by 2 z inverse minus 20 divided by 1 minus 1 by 4 z inverse. And we know that a to the power n into u of n, z transform is 1 by 1 minus a z inverse, and the given ROC is mod z is greater than 0.5. So therefore I'll get here ROC is outside the circle with the radius 0.5 or 1 by 2. So you get both the terms, both these two terms are right sided sequence. Now you can take the inverse transform. Again I need to obtain the time shifting property of z transform, because here one more term is there, z square. For this particular term I have to apply the time shifting property. So first I will take the inverse transform of this, then I will apply the time shifting property. Therefore x of n is equal to z square. I know that the inverse transform of a constant is delta of n, it is 1 is delta of n. So here 8 into 1, that is 8 into delta of n, plus 12 into 1 by 2 to the power n u of n, minus 20 into 1 by 4 to the power n u of n. So as I know the transform this particular equation. Now applying a time shifting property. So what is time shifting property? Time shifting property is given by the Z transform of x of n minus n naught. Z transform is given by z to the power minus n naught into x of z. So here I can compare this. Here z square is there. So z to the power minus n naught means here n naught is minus 2. So signal is shifted left by 2 units. Right? So that will be x of n plus 2 now. So wherever n is there, you replace by n plus 2. Because everything here in terms of n only. So this is z square. So I need to apply time shifting property. Then I had convert it to a time domain signal. Right? So wherever n is there, I replace by n plus 2. Now using time shifting property, I'll get x of n is equal to 8 into delta of n plus 2 plus 12 into 1 by 2 n plus 2 into u of n plus 2 minus 20 to 1 by 4 to the power n plus 2 into u of n plus 2. So this n is replaced by n plus 2. So this problem is appeared in the model question paper also. So the ROC is given with z is greater than 0.5. So if it will be given by mod z is less than 1 by 4 or 0.25, then we will get a left-sided sequence. All these are left-sided sequence. So next, one more type of problem. That is the third type of problem here. That is, find the inverse Z transform from the following sequence. The x of z is equal to 4 minus 3z inverse plus 3z to the power minus 2 divided by 1 plus 2z inverse into 1 minus 3z inverse whole square. And the ROC is given mod z is greater than 3. See, by looking at this equation, you can observe this order of the numerator is 2, whereas order of the denominator is here z inverse, here z to the power minus 2. If I'll expand it, I'll get z to the power minus 2. So if I'll multiply these two, I'll get z to the power minus 3. So order of the denominator is 3. So m is less than n, you can apply partial fraction method directly. But one important observation is here I am having 3 poles. One is at minus 2. One pole is present at minus 2, and the 2 poles are present in the same location. So because of square, there are 2 poles are there present at 3. That is equal to 3. There are 2 poles are present. So this is called as multiple poles or similar poles. Now to solve this problem, by using a partial fraction method, I write like this: a divided by this x of z is equal to a divided by 1 plus 2z inverse plus b divided by 1 minus 3z inverse plus c divided by 1 minus 3z inverse whole square. So I will take one more constant here. And there, this is because of the square, I will take one more constant, c divided by 1 minus 3z inverse whole square. Cross multiplication again, a into 1 minus 3z inverse whole square plus b into 1 plus 2z inverse into 1 minus 3z inverse plus c into 1 plus 2z inverse, and the x of z, that is numerator, is 4 minus 3z inverse plus 3z to the power minus 2. Now we have to find out the values of a, b and c. So first I will find out c. So for that I will put z inverse is equal to 1 by 3. Z is equal to 1 by 3. So I will get this get cancels, even this also get cancelled. So these two terms are 0. And here I will get c is into 1 plus 2 by 3. 1 plus 2 by 3. 4 minus 3 into 1 by 9. So the right side will get 10 by 3. So here I will get 5 by 3. Therefore c is equal to 2. The next I will find out for z inverse is equal to minus 1 by 2. I will put z inverse is equal to minus 1 by 2. Here a into 1 plus 3 by 2 whole square is equal to 4 plus 3 by 2 plus 3 by 4. So I'm substituting this in this particular equation, that is Z inverse is equal to minus 1 by 2. So this is my equation 1, and here I'll substitute all the values. So I'll get 5 by 2 whole square, 16 plus 3 divided by 4. So it is 25 by 4, and here also 25 by 4. So A is equal to 1. So I got the values of C and A. Now I'll put Z inverse is equal to 0 in this particular equation to find out the values of P. So put Z inverse is equal to 0, I'll get A plus B plus C is equal to 4, and here this is B, okay, this is B, so B is equal to 1. I know the value of A and I know the value of the C, because A is equal to 1, C is 2, therefore B is equal to 1. Therefore X of Z is equal to 1 divided by 1 plus 2Z inverse plus 1 divided by 1 minus 3Z inverse plus 2 divided by 1 minus 3Z inverse whole square. Now I need to take the NOZ transform of this particular equation, and the ROC is given by mod Z is greater than 3. So there are 3 poles are there, one is at minus 2, other one is at 3. So 3 is greater than 2. So ROC is outside the circle with the radius 3. So this is ROC. Right. Now here the first term I can take NOZ transform directly. I know the NOZ transform this, and second term also no problem. But third term here it is given by 2 divided by 1 minus 3Z inverse whole square. So here in the denominator square term is there. So the inverse transform of this, if it is a square term is there, means I am multiplying with the ramp signal. So you can write this here, a to the power n u of n is Z transform is 1 by 1 minus AZ inverse. Similarly, n into a to the power n into u of n, it's Z transform. You can observe this in a table, Z transform per table. N into a to the power n u of n, Z transform is AZ inverse divided by 1 minus AZ inverse whole square. So you can observe, if I'll compare this equation and this particular term, you can observe here, this is, if I'll take this 2 outside, then it is 1 by 1 minus 3Z inverse whole square is there. Here it is AZ inverse divided by 1 minus AZ inverse whole square is there. So denominator I am having 1 minus AZ inverse whole square. So numerator I am having only 1. So I need to obtain this particular term AZ inverse. Okay. If I'll bring this third term to a standard form, then I can take inverse transform directly. So to obtain that, you take this particular term separately first. Consider the third term from equation 1 is 2 divided by 1 minus 3Z inverse whole square. Now I'll multiply and divide by 3Z inverse. So I'll multiply and divide by 3Z inverse. So here 3Z inverse and divide by 3Z inverse. If it's Z inverse, and if I'll go to the numerator, then it will become Z. So I'll take it to the numerator, and this 3 and here 2 by 3, 3Z inverse divided by 1 minus 3Z inverse whole square. So this, if I'll consider this 3Z inverse divided by 1 minus 3Z inverse whole square, then this is in the standard form. Therefore, equation 1 can be written as X of Z is equal to 1 divided by 1 plus 2Z inverse plus 1 by 1 minus 3Z inverse plus 2 into 3Z inverse into Z divided by 3 into 1 minus 3Z inverse whole square. So here you can observe 3Z inverse divided by 1 minus 3Z inverse whole square. For that I can substitute here n into 3 to the power n u of n. Again, there is one more term is there Z, and 2 by 3 I can take it outside, 2 by 3 Z into 3Z inverse divided by 1 minus 3Z inverse whole square. Now in the previous problem you know how to apply the time shifting property. There we have taken Z square, whereas here Z is there, Z. So here also you can use the time shifting property, and that is X of n minus n naught, its Z transform is Z to the power minus n naught into X of Z, and here Z is there, Z to the power 1 it is. Therefore I can take n naught is equal to plus 1 plus 1. Therefore, x of n plus 1 its Z transform is Z into x of Z. Right. Now I'll take the inverse Z transform this particular equation. For the ROC, the magnitude of Z is greater than 3. Therefore, x of n I'll get minus 2 to the power n into u of n, because a is equal to minus 2 here. Minus 2 to the power n u of n plus 3 to the power n into u of n, the right sided sequence, and 2 by 3 n into 3 to the power n u of n. Because of time shifting property, I'll write it as n plus 1. Wherever n is there, I have to replace by n plus 1. So n plus 1 into 3 to the power n plus 1 divided by, into u of n plus 1. This is my final answer. Minus 2 to the power n u of n plus 3 to the power n u of n plus 2 by 3 n plus 1 into 3 to the power n plus 1 u of n plus 1. So n is replaced by n plus 1. So here I applied a time shifting property and I taken the inverse Z transform. The ROC is Z is greater than 3. These are the problems related to partial fraction method. So there are 3 types of problems are there. One with the order is order of the numerator is less than the denominator, so you can apply partial fraction method directly. The second type of problem is the order of the numerator is greater than or equal to the order of the denominator. So at that time apply long division method, convert your rational function such a way that the order of the numerator should be less than the denominator. Second case. And third is multiple poles or similar poles represent the same location. The third type of problem. And as I solved all the problems in terms of inverse powers of Z, in the problem if they are mentioned in positive powers of Z, convert it to a inverse powers of Z, then apply the partial fraction method. So this will be easy. So you can solve by using a positive powers of Z also, but better if you follow this method only for all the problems, it will be easy. So in the next class we'll discuss about the power series expansion method. That is one more method to obtain the inverse Z transform. So directly we are expanding the equation and we'll obtain inverse Z transform that.